Ron Rodriguez, Group 28, demo for assignment 4. See the potentiometer. We're in decimal mode with the ADC on the screen. Turn it to the left, and we see that the bars decrease, and the value of the ADC is going down to 385. We can turn it all the way to the left, and it'll go to 0. And we turn it all the way to the right, slowly incrementing. As the resistance increases, the voltage increases, and the ADC value will read higher. So it's at its maximum at 1023. We can press X on the keypad, turn it to hexadecimal mode. We can turn decimal back by pressing D. Let's set it to the middle. Press X, hexadecimal mode, D, decimal mode. And then we can have the buttons. Push button 1 takes it from equal sign to star. Push button 1 again, or 0 again, goes back to bar or to equal signs. Push button 1 takes it to an arrow. Press it again, go back to equal signs. Push button 2 goes to X's. Push it again, goes back to equal signs. Push button 2, push button 1, push button 0. Push button 2, so you can switch between any of the states freely. And if you double press the state, you will go back to the initial state start. Okay, so that's the full demo. We can now look at the code, which I will move everything out of the way. So we start in main by initializing the ADC sample. That's the variable that will take in the ADC sample. Machine state is set to state start. The receive char comes from the UART ISR, and bar char is set in each of the states. There are 4 states. We initialize the ADC. We initialize the pins for the port pins for push button 0, 1, and 2. We initialize UART2, initialize interrupt on change for negative and positive edge for each of the push buttons. Then we go and start the timer at a timer 3 interrupt of 0.125 seconds. And then we go into the super loop, go into idle. If an interrupt happens, we check the interrupt, which interrupt caused it. We do interrupt updates. And then once we have the updates, we go into the state machine and using the ADC sample and the machine state, and it will pick the next state based on the button pushes and various inputs. So do interrupt updates checks the UART RX flag. If it's been triggered, that means that there's been a key press. And so we change the display mode with set display mode, which will change from hexadecimal to decimal. Let's reset the flag. If there was an ADC event from the analog to digital interrupt, we run the function do ADC to grab the sample and put it into the ADC sample dereference pointer, and then we reset the flag. If there was a timer interrupt every 1 second, or counter 3 mod 8 equals 0, we will clear the screen, return home, display the bar graph, and then display the ADC value from the ADC sample. And we can see what some of these functions do. So there's a set display mode. If received char is X, set to disp mode 1 for hexadecimal. If received char is D, this mode is 0. Display ADC will display the ADC equals, and then if this mode is decimal, it will use the disp to des ADC sample. Otherwise, it'll use disp to the hex ADC sample. The bar graph is created by making 51 divisions by dividing the ADC value by 20 by the number of divisions to create the number of bars that are displayed. And then XMIT UART displays that bar char a number of bar times. And then check push buttons, checks the push buttons states and sets them. And then it goes into the state machine, which will set the state. If you're in state start, bar char is equal. If you're in state PB click, your bar char is star. If you're in state PB click 1, you're an arrow, and your PB click 2, you're an X. And that's the full operation. It does the interrupt updates and then sets the next state according to the push button logic.